So we're finishing up Unit 4 today, and so last time we talked a lot about metric system, about American system, and we also talked about how to cross in between those two. Now, we are talking about something like this. What if we have and there will be problems like this, which is a little bit tricky. So we are now going to geometry. And I'm going to include some of those metric systems in there, right? Some of those units. So we have like a rectangle, for example, right? Say this is 4 centimeter, and this is 3 centimeter. Now, it's the usual stuff, right? We're looking for the parameter and the area. Now, if you ever forget how to find the parameter, how to find the area, you remember I gave you the formula sheet. On the formula sheet, on the first 2 pages, right, you will have all the first page is all the areas in the parameter. The second page is all the volumes. So if you ever forget, you can always use it. The rectangle is pretty easy because the parameter is always the outskirts, the outside of everything. So in this case, it's 3, well, you have 2 3s, right? You have 2 4s, right? That's 2 length plus 2 times width. Basically, double the 3, double the 4, add them together. So like this, right? So that's what 6 plus 8, which is that's 14, right? And remember, that's 14 centimeter. I will not take points off on final, just because the units isn't right, but it's good to know. So that's 14 centimeters. Whereas area is always length times width. And in our case, right, is 3, length is 4, right? So 4 centimeter times 3 centimeter. And 4 times 3 is 12. And you're like, wait a minute, I have double the centimeter, multiply together. Well, if x times x is x squared, or 2 times 2 is 2 squared, centimeter times centimeter will be a square centimeter. Kind of like the floor plan, right? If you have a square foot, square inches, right? And that's because it's an area. Area is a 2D. This is a 2-dimensional entity, whereas this guy is 1 dimension, 1D. So 1-dimensional, just centimeter. 2-dimensional, now you're talking about square. And you can do the same thing with like triangles. So let's do that one. So triangle, like maybe like this one here. This. One triangle looks terrible. How about this? And I'm gonna say this is how about 3 feet. Then the height. I'm gonna call this, let's just say this is 5 feet. So notice that for a triangle, the area is always gonna be 1/2 times base times height. Or some people just say base times height divided by 2. That's how I always learned it, but I think that's how they put that in the formula sheet. Base times height divided by 2. And you know, what's base? Base is always the bottom guy, right? So in this case, it would be 3. Right? 3 feet, right? And what's the height? Height is always, so some people might question, hey, the height, some people will look at this line right here, or maybe this line. Well, the height is from the top of the triangle directly to the ground. So that's why it has to be like this. This is the height. So 5 feet. And divided by 2, and that will be 15 divided by 2, right? 15 over 2 is what? 7.5? So that's 7.5. Again, it's square feet. Because it's a 2-dimensional area. It's 2-dimensional. The triangle is not so bad. Rectangle, triangle. Square is the same thing as rectangle. It's just because square is it's a type of rectangle. It's a specific case of rectangle. Now here's another one that's kind of confusing. What about a parallelogram? So let's say this is 3.7 meter. And I'll do the same thing here. This guy right here, let's just say this is 2.1 meter. It's kind of the same situation as before, where the height of this parallelogram is always from the top of the objects, right? From the top of the shape down to that ground level. So, and the area is always the base times the height. It's kind of like the rectangle, right? It's got length times width. It's almost like that. And base times height, in this case, will be 3.7 times 2.1, right? Just put this in the calculator. And let me see. I have 7.7. 777, you know what? I like that, I like that. So go to the casino today. And who knows, right? I'm gonna get to that lottery today. Did anybody win the half a $1 billion? No? I'm gonna get some more. I'm gonna get some Powerball. Like I said, if I win, Gavin, don't worry about Hyundai. We're gonna be all right. We're gonna be all right. We're gonna buy a Hyundai, you know what I'm saying? We'll do whatever we want. I'm telling you, that's a promise. You see me on TV, you see me getting that money, come on over. And remember, this is square meter, right? Because it's area. So in other words, this guy is kind of the rectangle. If you think about it this way, let me show you a picture. If you take this piece right here, take this piece right here, and surgically remove that and put it over here, don't you get this piece? Don't you get it like this? You see what I'm saying? So if you take this guy and move it over here, doesn't that become a rectangle? And the height is kind of like your length or whatever, right? That's why the area will still be length times width, almost like length times width like this, because you can move it to the other side, become a rectangle. So this one actually makes some, it makes some sense, right? So, now, what about the next guy's kind of, it's just weird. A trapezoid. So let's say the bottom is 47 inches, right? And the top is, let's just say 11 inches. And then I say the height is, let's say 8 inches. So the question is, what is the area? So it turns out the area of a trapezoid like this is always gonna be the height multiply what is called B1 plus B2 all over 2. And you know, what's B1 and B2? It's just a fancy way for them to say, this is the ceiling, and this is the floor. That's all it is. Meaning, B1 is the guy on top, B2 is the guy at the bottom. That's it. And the height, of course, is 8, right? So it's the height times you divide it by 2, the average of those two guys. The average between the top and the bottom. So if you plug it all in, right, that's 8 times B1 is 11, right, plus 47, right, divided by 2. And that's 8 times, what is this, 58? Okay. And divided by 2. What is that? I'll just do 8 divided by 2 is 4. 4 times 8 is 32, and then 232. And oh yeah, and I gotta put square inches. That's inches, right? So square inches. I don't think that's a way to write square inches without, with the symbols. So trapezoid is not too bad. It's just weird, right? It's not something you see every day. So you guys okay? What is those? These guys are pretty basic, right? Now the circle is the one where needs some special attention for this one. So for circles, you have to deal with these guys here. The circle that's been given, oftentimes they will give you the radius. So they want to say this is like, 4, 4 kilometers or something like this. So this is the plan you're writing. You're making out for like a field or whatever. That's your parameter, a 4 kilometer parameter. And there are 2 things we're looking for. We are looking for the circumference and we are also looking for the area. This actually have more military applications, which I actually had to do most of the time, because back then when I was doing chemical, nuclear specialist, right, is that I need to figure out where to put my machine to detect those chemical attacks. And those machine has a radius, right? I forgot what it's in meters, I think the exact range is 1,000 or 2,000 meters, I forgot what it was. But you have to draw on a map. Hey, this is good for this coverage. Kind of like your radar, your cell phone signals. Those cell phone towers, they're good for here. And if you go to Port Wentworth, you don't get no signal. Well, I don't get no signal in Port Wentworth. And I don't know if you ever noticed the signal map is when you go to let's say you drive down to Hollyfield, it's usually the signal's only good along the interstate or something like that, along the roads. And as soon as they get into on the outside, unless you're using Verizon, right, then I think you'll be all right. I don't know what you guys are using, but I use AT&T, and that stuff is It's not very good around here, I'm just gonna tell you. I rely on Wi-Fi most of the time, so. But it's unlimited data, and it's on my sister's plan, so I don't pay for it, so you know what I'm saying? So that's the only reason I keep it. But with this guy, it's how do you find, I wanna first find out the parameter. So I know how many wires I need to go on the outside, or whatever the list I'm doing. Well, parameter is the same thing as the circumference. Circumference is just a fancy name to call a parameter of a circle. And the circumference is always C equals 2 times pi times radius. And pi, you remember, is roughly, you got it. Now it's not exactly 3.14, it's an approximation. It's just a guess. Nobody knows what the exact answer is. Pi is along with that. Actually, people have been trying to study this since like, I don't know, thousands of years ago. There's a Chinese dude, that's one of the first math I learned. This is from 2,000 years ago. This is from the first emperor's era. So he was trying to calculate this, except at the time, you don't have those long division we had. We didn't have those concepts. But he was trying to figure out the relationship between the radius and the outside. Because he was trying to make like shields and stuff for people. And just a little bit of Chinese history, okay? The first emperor, the Qin dynasty. That's why people call us China. That might had to do with Qin dynasty. I don't know. But anyway, because we don't call ourselves China in China. In China, we call ourselves we're the middle country, or the central country, like, because we're in the middle of everything, in our mind. So, in our mind, and you can look at our culture, right? We definitely think that we're self-centered. We believe we're in the middle of everything, right? You must see that today, some of the ideas that are coming out from Chinese, right? So, but anyway, during the first emperor, during that era, he had to conquer 6 different kingdoms. So there were 7 kingdoms that kind of like Game of Thrones on this. But there were 7 kingdoms that has all the lands of China, and this guy wanted to take over all the other ones, right? So one of the things they did was that anybody who make a weapon, you have to sign a name. So you make a weapon, and the blacksmith and all that, they will sign a name, right? Then there's an inspector from the government. They will sign a name. Okay, this is good to go. Then there's a guy who will transport that weapon to the front line. He will sign his name. And the soldier who hold that shield will also sign his name. So that equipment has 4 names on it. Now, if they go in battle and this thing breaks, it was not effective, the soldier will not be blamed, all right? He just got to look at maintenance, right? But the guy who made it will be killed. The guy who inspected get killed. And the guy who transport, depending on how things goes, might also get killed. And so that's how it was. So he want to make sure the shield's gonna work out. So he want to make sure everybody's all right. So, but yeah, he actually figured out the pi at the time. So that was actually pretty impressive. But this is a mystery, even to this day. Nobody knows the exact answer. And some people say, hey, instead of the same thing as 22 over 7. 22 over 7 is also an approximation. So this is also approximate to this. But for most part in real world, we just deal with this guy, right? When you do your homework, I know it's tempting. On your calculator, there's a pi button, and most people, let's just press that, right? Well, here's the issue. That's how you do in real life. In real life, you press that button. But in fake life, right? In math life, in horse learning life, they want you to use 3.14. Just make them happy. Just do 3.14. On the final exam, I don't care. I know if it's the right answer, okay? So it might be a little bit off, but I know what you're doing. But anyway, let's plug all those information into this guy. This guy is the radius. R equals to 4 kilometers. All right. Radius is always the half length between the center to that circumference, right? To the outskirts. So that's 2 times 3.14 times 4. And that's input kilometer if you want. So that's let's put the calculator. 2 times 3.14 times 4 is 25.12 kilometers. And that's the circumference. It's not too bad as long as you know the formula, right? That's why, by the way, this formula is available on your formula sheet on page 3, on the dirt page. That should be the circumference, and then you have the area. It's just that the formula, they also include the diameter, but I'll talk about those. Now let's talk about area. What's up the area? Area is always A equals pi times radius squared. So it's almost the same thing like, with the pi, the radius, just gotta plug it in. So this guy is 3.14 times, 4 kilometer squared. So that's what 3.14 times 16. Are you okay? This is gonna be square kilometers, right? 3.14 times 16, but it's square kilometers because you square everything, right? So just put in your calculator. 3.14 times 16. I have 50.24 square kilometers. So what that means is, if I have this, let's say you have a radio tower, that's good for 4 kilometers, or a cell phone tower. They always got new cell phone towers, new signal, LTE or 5G. Nobody really know what it means anymore. I don't know what it means, but you can actually map over the towers. They have an effective range, and that's the range we're talking about. You can know that that's the area, and that's the circumference. Right? For me, it's more about, let's say in the military, right? You're gonna set up barbed wires or whatever, right? Barbed wire, man, that's the Constantino wire, that's what we call it. That's a good stuff, right? You're gonna roll it out. And it's a curse, because I got torn up here. I got torn up in the back as well, because I was messing around. Well, I drop it. And if you just don't move, you'll be all right. But I was trying to get out of the way. Then from that point on, you know what? You gotta train your mind not to. Continue drill. If it drops on, just let it go, because it can hurt pretty bad. Now let's do another circle, because on your homework, they're gonna get something. They're gonna get some circle that's just a little bit crazy. So if I give you a circle like this, and I say, this guy is, how about 11 feet? So you see the problem there? They did not tell you the radius. They gave you the diameter. So the diameter equals 11 feet. And diameter is the full length of the circle from one end to the other. It has to cut through the center though, right? It has to cut through the center. And as it implies, radius is the half length. So the radius is simply the diameter, I call it D, divided by 2. So you always gotta do this first. Anytime they give me diameter, I find a radius. Then I start to go from there. So that will be, radius is 11/2. So that means that's 5.5 feet, right? So you gotta use this guy. And then after that, it's not so bad, right? You gotta use the circumference. It's gonna be 2 times 3.14 times 5.5, right? Which is, what is it, calculator? And area is gonna be pi times radius squared, which is 3.14 times 5.5 squared. So just put that in the calculator. You can so basically for 5.5 square on your calculator, you could just do 3.14 times 5.5, and then multiply by 5.5 again. So do it twice. So that's what I have right here. Square feet. Again, square feet because it's area. And again, I'm not gonna take points off for the final. And in fact, your homework never asks for it. They will give you the units. If you go to like a science class down the road, so like as I mentioned, right, some of you guys want me taking chemistry or biology here. I know, Samantha, don't you ever take chemistry?
Yeah, we have to take science.
I see. And I think Andre, don't you ever take some over here too? Some science classes? So when you take science, right, for any medical, you need that stuff, right? So, you know, you need to take some of those. And when you're in a science class, they will take points off of that stuff. But you gotta understand though, in a science class, like, you can't, if you have the wrong units, that can be a difference between, I don't know, explosion or something like that. You know, it all depends on what you put it in, right? So you gotta be careful. In math, all we care about is the numbers. We don't care about you. I wonder if they're gonna offer physics, and I want to take some. I took physics way back when I was in the army. Like that was like my last. I think one of my last class that I took. But I never took that in. I've never taken it. You know, but when I was in UNCC. Oh, crap, Miss Rodriguez, did you?
I'm fine.
Okay. You can copy off Samantha or something like that. So take a picture of her note. I know she got good notes now, you know what I mean? So now, let's do some volumes. Volume is always the more difficult of the two because it's just ridiculous sometimes. And then we'll do some more difficult problems with these guys. So volume is say we got like this thing. So this is a cubicle, right? And let's say this is 8 centimeters. And this is also 8. And the depth is also 8. So you can think about this as like length, width, and height. And we're looking for the volume. The volume of a cube is always length times width times height. So as you multiply those three, you're good to go. I like this one. So that's 8 centimeter times 8 centimeter times 8 centimeter, right? And then put in the calculator. 8 times 8 is 64 times 8 is 512. So this guy's 512, and that will be centimeter to the third power. So cubic centimeter. So what that means is volume is always gonna be 3-dimensional, right? So this guy's 3-dimensional. The 3Ds. Nobody can watch wrestling, dude. Nobody watch like WWE. So 3D is my favorite wrestling move. Just one. You can Google. 3D is when, let's say Gavin and I put a move on Andre. I will lift you up like this, and then Gavin would jump and do like and hold your neck, and then we will drop at the same time, so you will like get hammered in like your head and your neck. Go, that's my favorite move because you gotta coordinate your movement, you know what I'm saying? But my favorite tag team of all time is 3D, and that's the Dudley Boys. Check it out. They're hardcore now. They jump off table and off the cage and stuff. Now, here's another one. How about a sphere? Right, like this. So like a circle, like an Earth or something like this. Earth is not a perfect sphere, just in case if somebody want to study, planet and stuff like this. But as people calculated the mass, the volume of Earth in the early days using this formula, which is, let's just say the radius here is 4.2, feet or something like this. How about this? What's the volume? The volume of a sphere is always going to be the what is it? I think it's 4/3 pi times radius to the third power. Let me double check just to make sure it's right. Because stuff like this sometimes I forget. It's on your second page. Yep. Oh, they write differently. They write 4. So on your formula sheet it says 4 pi radius to the third power over 3. But are you okay? This is the same thing. It just, I just write that 4/3 on the side, but they put it together. Doesn't matter either way. I guess we'll stick with this one if you want. So that's the volume. And all you gotta do, man, is figure out, hey, the radius is 4.2 feet. So just take that information, bring it in. So that's 4 times 3.14 times 4.2 feet, right, to the third power, over 3, right? And if I was shooter, I would put everything in the calculator if you can, right? If you have a calculator that works like this, right? I would just say 4 times 3.14 times 4.2 divided by 3. Just put it all in the calculator. And just say 17.584. So that's cubic root to the third power. Again, this is a volume, so it's a 3-dimensional object. 3D. And you also see stuff like this one. This is like a cylinder, is that how you say? A cylinder. And let's say the radius here is, let's just say it's 5 centimeters. And the height is 10 centimeters. I want to know what's the volume. So all those information has to be given to you, right? So okay. Well, the volume of a cylinder is always, the way I remember is this. It's always this area right here multiplied by the height. Well, the area of a circle is pi times radius square, right? All you gotta do is do the area, then multiply by the height. So it's gonna be like this. It's on your formula sheets as well, right? And you can plug it in, so that's 3.14 times 5 square times the height, which is 10. Right, that's right. And once again, just put everything in the calculator. Just put 3.14 times 5 times 5 times 10. And I have 785 cubic centimeter. Because that's the volume, right? Understand? So is it pretty boring? Is it?
For the
Yes,
second
ma'am.
one, I did not get 17.584.
Let me try that again. I could be wrong.
I don't know if I'm putting it in the calculator wrong.
Oh, you know what? You're right. You're correct. I messed it up. My bad. Thank you, Samantha, for correcting this. It's 310. Is that what you got?
Yes.
And one. I'm gonna round to 2 decimal places for 1/8. Thank you. I forgot I hit the third power. My bad. My bad. But this is pretty boring. you just you get a bunch of numbers, you plug into the formula. But this is what geometry, at least the basic geometry. And most people, if you have to do geometry, that's all you gotta do, right? Like back in the military, I did the same thing. Nobody's gonna be doing crazy geometry until now. This can get ridiculous now. What if you have, think about it, right? What if you have a cylinder like this, right? And you try to fill it up with water. Let's say you fill it in water, right? And the water level is at maybe 2 centimeters. And I'm telling you, this is 5 cubic centimeters per second. How long would it take before this guy will fill up? You know what I'm saying? Now, what if I drill a hole in here, and this thing would be out by, let's say, 8 centimeter cubic per second. So you're gonna put water in as water coming out. When would this guy be empty? You see that stuff can get crazy, right? This stuff is, but don't worry about it. This right here. So these are the foundation for those type of problems. Why are those important? Why are those things important? Because, for example, I brought my daughter to the pool, last night, and if they want to empty out the pool, how long would it take? Right? If you want to calculate how the pool has the cleaning system and all that, how do you calculate the inflows and outflows? Right? Those stuff. If you're interested in this thing, you want to learn about those stuff, you will need to take calculus, then Calc 2. Then there's a class called differential equations, DEQ. That's the engineer class that everybody, computer science, everybody got to take. And they usually suck at it, I'm just gonna be honest. Engineers, I was good at it. I was good at it. Math major would do well. And we'll be in the same class with engineers and mathematicians. The math majors would be like, this is easy. And the engineers would be like, they'll be scratching their head, how do you do this? That's it. It's just, because it's not the most intuitive. Some of these stuff goes crazy. Now, I think we still have like a couple of problems like this right here. Oh, you know what? Let me draw a bit better. So this is how do you call this? Like a cone? Is that how like this? Yeah, my drawing side. So let's say the radius is, let's just say 2.3 inches. How about this? And let's say the height, right? The height is, let's just say 8 inches. I want to know what's the value. So in this case, you just gotta look at the formula sheet. On the second page, on the cone, volume is pi times radius squared times height over 3. Now this guy right here, you know the radius is 2.3. And you know the height is 8. So all you have to do is take those information, plug it in, and that's 3.14 times 2.3 squared times 8, all over 3. Let's plug it in. So 3.14 times 2.3 times 2.3 times 8 divided by 3. So what you got? I got 44.295. They just do 3 decimal places. So that's cubic inch. Right, 5. So that's how you calculate the volume of a cone. I don't know, you guys ever wonder how we even come up with formulas? Anybody remember and think about it? I never thought about it until calculus 2. In Cal 2, you will actually learn how to get the formulas in the first place. So that's what the math to get those. Because you gotta think about, right? Right now it's the cone, but what if this thing is rotating? You ever think about, like, if, let's say this is like a rocket ship or something like this, and this thing just rotates. How much area is it gonna take? How much volume is it gonna take? Those are the stuff you deal with in calculus. Again, it's not very useful practically to life, unless you're an engineer. Right? Even for math major, we don't really use that. We just know how to do it. So are you guys okay with these volume things so far? And you guys want to take a break with us? And we'll finish up the problems. All right, so let's take 10 here.